Hi, and welcome to this quick tutorial on the SAM2 segmentation tool in Imalytics Preclinical. SAM2, which is short for Segment Anything Model 2, is an AI-powered tool that lets you segment structures in your 3D images by drawing a simple bounding box and adding a few prompts or clicks, instead of manually segmenting slice by slice. In the next few minutes, I'll walk you through the full workflow: drawing a bounding box, running the image encoder, adding prompts, propagating the segmented mask across slices, and finally, merging the result into your final segmentation. For this tutorial, we will try to segment the tibia epiphysis of a mouse using the SAM2 tool. As you can see, I have the dataset loaded in here, so let's start our segmentation. To get started, select the SAM2 mouse mode from the main toolbar. You'll see a new toolbar appear at the top of your screen with two main buttons, the bounding box mode and the prompting mode, along with some extra options we'll get to shortly. By default, you're in the bounding box mode. This is where every SAM2 session starts. To create a bounding box, simply click and drag on any slice view around the area you want to segment. As you drag, the box expands. The box is three-dimensional, so it appears in all three slice views at the same time. However, it does not appear in the 3D view, as the user cannot run SAM2 in that view. There are a few things to know about the bounding box. You can resize it by grabbing any corner and dragging, in any slice view. When you hover over a corner like this, your cursor will indicate that you can resize it. You can pan it by clicking near the center of the box and dragging. For this, the cursor changes to a hand icon to let you know. The box has a minimum size of 4x4x4 voxels, so if you try to resize past those limits, you'll get a warning. So let's try to capture the tibia epiphysis with our bounding box. To ensure that I get every section of the epiphysis, I can resize all corners in every view. This can take some time, but this allows the model to run on a subsection of the image, which can speed up the computation as it does not have to process the entire volume during inferencing. You can also run SAM2 on either the underlay or the overlay. To specify which layer you would like to segment on, please select it before running the image encoder. Also consider that you will not be able to perform SAM2 on another layer without resetting SAM2 first. Okay, once your bounding box is sized around the region you want to segment, it's time to run the image encoder. If you've decided to not add a bounding box, SAM2 will simply run on the entire image. To run the image encoder, we need to click the Start Image Encoding button. You'll notice an outer padding value next to it. That's the value SAM2 uses to fill any out-of-bounds voxels during cropping. The default is usually fine, but you can adjust it for unusual cases. When you click the button, you'll see a dialog showing the region defined by your bounding box if you added one that SAM2 will work on. In this dialog, you need to pick your propagation view, either the axial, coronal, or sagittal view. This is the view SAM2 will propagate through, so choose the plane that best shows the structure you're trying to segment, as this will help the model perform better. By hovering over each option, you can see what the structure looks like as you propagate through every slice in that view. The image encoder will start running as soon as you confirm your selected view. Behind the scenes, this step converts your cropped 3D image into an internal feature representation that SAM2 understands, basically teaching the model what's in your region of interest before you start prompting. It usually takes a few seconds depending on the size of the structure in your bounding box, which is why we've added a progress dialog which lets you know when the image encoding process is done. Once the process is done, we enter prompting mode, which can be identified by looking at the selected option at the top left right here. Now comes the interactive part, guiding SAM2 to what you actually want segmented. You can add two kinds of prompts: positive prompts with a left click on areas that should be part of your segmentation, and these appear as green markers like this, and negative prompts by combining shift and left click on areas that should not be part of it, and these appear as red markers. You can add prompts on any slice. As soon as you add a prompt, SAM2 runs inference on the current slice and shows you the result as a blue mask overlay. You can adjust how transparent that mask is using the opacity slider on the toolbar in case the mask is covering anatomy you need to see. If the mask extends somewhere it shouldn't, add a negative prompt there. You can add as many prompts as you need. SAM2 reruns inference after each click. Now there are a few things to consider. Prompts can only be added in the propagation view you chose earlier. If you try to click in another view, you'll get a message reminding you like this. Prompts must also stay within the bounding box region you defined. That's the area SAM2 has encoded, so anything outside of that is invisible to the model. Let's continue adding annotations until we think we have enough slices for the model to be able to propagate across all slices by itself. It can be useful to add annotations in the first and last slices to help the model understand that this is where the propagation should start and this is where it should end. Once you're happy with the mask on the current slice and the other annotated slices, it's time to propagate across all slices in your chosen view. So click Start Propagating, but before you do, you can tweak two settings. First, conditional frames. This controls how many nearby slices SAM2 uses as reference when inferring each frame. More frames means more consistent results, but slightly slower propagation. The default of 4 works well for most cases. Second, use multi-mask output. When enabled, SAM2 picks the best of 3 candidate masks on the first frame. You can try turning it on if the initial segmentation doesn't match what you expected. Once you click Start Propagating, the propagation runs. Depending on the size of the selected structure, the propagation can take some time. If you open the command line like so, you can see each frame currently being segmented. Once complete, you'll see the mask fill in across every slice in the propagation plane. Scroll through the other views and you'll see the 3D extent of the segmentation. If you are unsatisfied with the final segmentation, you can add prompts to a few of the slices that have been segmented poorly to correct the inferencing. Then, you can run the propagation again, and SAM2 takes into account your newly added prompts. Please ensure that the slices that have been annotated are as good as possible, as these slices will not be re-inferenced upon during propagation. Of course, you can still correct them by adding prompts. So let's correct a few slices and run the propagation again. You can repeat this process as many times as necessary. The final step is turning this mask into an actual class in your partition or segmentation. Before clicking Merge, make sure you've selected the output class you want. This is the class the segmented voxels will be assigned to. If it's currently set to unclassified, SAM2 will ask you to confirm since that's usually not what you want. You also have a Restrict to Input Class checkbox. With this enabled, SAM2 will only overwrite voxels that are currently in the selected input class. It's useful if you're refining a rough, pre-existing segmentation rather than starting fresh. So let's add a class called knee for our tibia epiphysis to contain the mask inferenced by SAM2. Then, click Merge Mask to Segmentation, and the mask is committed to your partition. You can now use it like any other segmentation, combine it with other classes, or run analysis on it to extract statistics. A few final notes. If at any point you want to start over, click the trash can icon to reset SAM2. This clears the bounding box, the mask, and all your prompts, and returns you to a clean state. SAM2 will also automatically reset if you modify the underlying image. For example, if you crop, downsample, or change the image that the box was drawn on. This is because the box's coordinates will no longer match the new image, so rather than silently misalign, the tool starts fresh and lets you know with a message. Finally, if you change your viewing rotation during prompting, SAM2 will restore it to what it was when you started encoding, since the encoded image is tied to that specific orientation. And that's the full workflow. Draw a box, encode, prompt, propagate, and merge. SAM2 is designed to get you from raw image to usable segmentation in under a minute for most structures, far faster than manual slice-by-slice segmentation. It works especially well for well-defined anatomical structures like organs, tumors, and bones, and gives you a strong starting point for more complex cases that you can then refine manually. Thanks for watching. If you have questions or run into issues, feel free to reach out to our support team.